We are now going to explore the malonic ester synthesis and the acetoacetic ester synthesis. Malonic ester synthesis named so because it comes from an ester of malonic acid. Malonic acid, oh my, such good apple pie. Start with 2 fingers in the air. O, oxalic acid. 3 fingers, malonic acid. Oh my. 4, such, succinic acid. 5, oh my, such, good, glutaric acid. And then 6, apple pie. And then 7, wait, oh yeah, pimelic acid. Apple is adipic, and then 7 is pimelic. Oh my, such good apple pie. Acids to die for. It's in chapter 17. It's not hard to learn, and those names keep showing up over and over again, especially when you start in biochemistry. So if you've learned the diacids, and remember that those start with 2 carbons because it's diacids, and then your teacher says, draw me alpha ketoglutaric acid, the intermediate in the citric acid cycle, and you can do it because you draw glutaric acid. Oh my, such good. You draw 5-carbon dicarboxylic acid, and he said alpha keto. You know what that means. Your fellow students in other classes have never heard these things, or they forgot it because it was on 1 test only, and they have no clue what alpha keto means. I bet everybody in this room could draw some carboxylic acid and put a ketone on the alpha carbon and know that that is correct. Okay, that's a lot of discussion for something not part of this activity. But for your future, learn the dicarboxylic acid. That's all I'm saying. So the malonic ester synthesis uses esters of malonic acid. That's what we just wrote here. The whole remaining part here is called the malonic ester synthesis. And I wish I could have stretched it out even more because it's for everything on the top of the screen. Well, let me grab it. Sure. Spread it out. And down here we have ethyl aceto acetate. And this whole thing down here is the acetoacetic ester synthesis. Synthesis. And what do you get during an acetoacetic ester synthesis? Highlighter says you get acetone with new groups on this alpha position. What do you get in a malonic ester synthesis? You get a malonic ester. Sorry, you don't get a malonic ester, I apologize. You get an ester of acetic acid with a new group up there. Acetic ester is highlighted. Acetone is highlighted down here. So if your target molecule has what you find is acetone in your retrosynthesis, you better be using an acetoacetic ester synthesis. If your target molecule has anything with acetic acid in it or an acetic derivative, then you better be using the malonic ester synthesis. And here we're doing the actual mechanisms, which are very straightforward. They take the alpha H, that's pKa 10. The whole beauty of these dicarbonyls is they have very low pKa's. We can get those H's off very easily. 10 is not a hard number to overcome. And you're making an anion. And if you want to do a nice short form, EtO2C taken twice, CH minus is what you just made. Nucleophile. Carbon nucleophile. Step 2, primary carbon with leaving group. What are you thinking? The only thing that happens is this, everybody. Right there. That's it. The red bond is new. How did it get there? Yes, attack the carbon that has the bromine. And the bromine does what bromine does. Leaves. Done. The synthesis part's pretty easy, isn't it? Take H off, do an SN2. That's the answer I was looking for. It's an SN2. Now, I'm going to repeat that you're never allowed to do this on a test, but we just did the rap song. I'm going to copy it again because I love it so much. Nope, missed. We did the mechanism for the rap song right there. Please. Here we are. Sorry. We're doing it again, but I'm going to just say you can't do this on the test. See prev page for mechanism. Please do the mechanism on the test, even if it shows up twice. It might. You'll look at some old tests and it does show up twice. Okay? And that's just to save us some time, okay? And in this one, I'll save us some more time. What happened here? You lost CO2 from one of the sides here, and you made this. What happens here? You lose CO2 from this side, and you make this. Guys, the answer for this box is on the page already. It's right there. It's the rap song. I'm going to copy the rap song. Reagents only. How do you do saponification, acidification, decarboxylation? KOHAQ, saponification. Acidification, HCl. Decarboxylation, heat of a beta, of an acid that's beta to a carbonyl. And you got that. And I think we're almost done. We just got to draw our intermediate here. And it looks like this time. Let's do it this way. Carbonyl minus EtO2C, backside attack, leaving group leaves, end of story. Oh, but there's another synthesis, so look at me. Here I was thinking we were done. Hey, if there's still more alpha H's, let's do this one more time. Double synthesis, double the fun. K, OH, grab H. We'll go with pink. A little more room here. I get the green. Aye, boo. Lone pair, backside attack. Leaving group leaves. End of story. Double synthesis. Beautiful. Now my label's out of position. I can edit that thing. Maybe I can. I can. Think. Gotta sneak it in here. It really belongs here. Right here. Yeah. Okay. And that's it for our, that's the material for our test. And I know some of you are saying he promised us an hour of review today. That was my estimate. I do want to point out one of our documents had a heavy amount of review on it. Our little roadmap earlier today. We did do some review. And that's it. And have a great break. And see you